Well, great. Last December, the Ohio River Valley Institute published a report called Stayin Alive, The Last Days of Stripper Wells in the Ohio Valley. The report chronicled more than 177,000 low-producing, what are called stripper wells in Appalachia. And it showed that many of these wells could be abandoned and would need to be commissioned at a cost of between 5 and 16 billion. Stripper wells, sometimes called marginal wells, produce fewer than 15 barrels of oil equivalent, which is about 90,000 cubic feet of gas per day. And they make up about 90% of active wells in the four-state region of the Ohio River Valley, which includes Kentucky, Ohio, Pennsylvania, and West Virginia. What is lesser known about these low-producing wells is the significant amount of methane they emit in Appalachia, despite producing just 7% of the oil and gas in the region. Methane, which is a primary component of natural gas, is a powerful greenhouse gas that has over 80 times the warming potential of carbon dioxide over a 20-year time span. Recent studies suggest that methane emissions from oil and gas production may be twice as high as the Environmental Protection Agency estimates. With that, a groundbreaking new study published in Nature Communications finds that low-producing wells, stripper wells in the United States, are responsible for 50% or half of all oil and gas methane emissions from well sites, and that these well sites allow approximately 10% of their gas to leak in the atmosphere, enough gas to run 3.6 million homes for a year. One of the authors of this study is Mark O'Mara, who is a scientist at the Environmental Defense Fund. Mark joins me today to talk about the study and why it will be critical for policymakers to take action to clamp down on these leaky wells, which is especially a big problem in Appalachia's Ohio River Valley region. Mark, thanks for joining me today.
Thank you for having me.
Yeah, this is great. I was very impressed with your study, and it's very apropos to the work that we've been doing at Orvie in the region, and it's very important, in terms of dealing with climate change. And that sort of leads me to one of my first questions about the study. Your study is focused on methane emissions from these low-producing oil gas wells in the United States. And all the headlines are usually about the high-volume fracking wells that produce the majority of the gas. They tend to get all of the headlines and the discussion. But lately, we've seen more discussion about these low-producing wells. And why should we be worried about the emissions coming from these wells?
Yeah, Ted, as you mentioned, low-producing wells are the most abundant types of oil and gas wells in the US. So about 80% of the nearly 1 million actively producing oil and gas wells in the US fall in this category. Now, despite their very large number, they account for only a small proportion of national oil and gas production, just about 6% in 2019. Now, importantly, even as their production rates continue to decline over the years, measurement-based data indicate that methane emissions can and do occur at these well sites. Now, as you mentioned, methane is a hard-hitting climate warming pollutant. 1 ton of methane emitted today packs more than 80 times the short-term heat trapping effect of 1 ton of CO2. And so these emissions from oil and gas operations contribute to the climate warming we are experiencing today, in addition to adverse public health outcomes, including degraded air quality, not to mention the billions of dollars worth of natural gas that's just wasted annually due to these emissions. And so, yes, if there are methane leakages occurring across the vast network of oil and gas infrastructure that's used to extract, that's used to process, that's used to transport oil and gas at low-producing well sites in other oil and gas facilities, those methane emissions are concerning on many levels.
That's really great. Yeah, so when we look at the entire, how much methane are we talking about? Is this a big chunk of the methane that's being emitted in the country, or is it a small amount?
It is huge. In our study, we estimate that 4 million metric tons of methane is emitted annually from low-producing wells in the US. And this represents about 1/2 of the total methane emissions from the US oil and gas production sector, and 30% of the total methane emissions from the entire US oil and gas supply chain. And so for context, 4 million metric tons of methane is enough natural gas to supply 3.6 million American homes or the annual residential natural gas demand for the entire state of Ohio. Now, according to the most recent estimates from the US Environmental Protection Agency, and apart from the methane emitted from oil and gas sources, there are only two other sectors that emit more methane annually than this. That is methane emitted from landfills and methane emitted from enteric fermentation in animal operations. In other words, methane emitted from low-producing oil and gas wells are significant. And our study suggests that these emissions cannot be ignored if large, meaningful reductions in climate warming pollution from US oil and gas operations are to be attained.
Yeah, that's a really great point. And one of the hard things about methane is it's like we can't see it, right? And sometimes if we don't see it, it's out of our mind. So if I'm based here in Charleston, West Virginia, and we have low producing wells all across the county that I'm in, hundreds of them. Actually, I saw one the other day going to the YWCA. I looked up and there's a low producing well right up the hill from me. So they're all over the place, especially in this area. But if I'm a landowner or I'm a royalty owner in West Virginia, I have several of these low producing wells on my property, and many of them might be emitting at high rates, of methane and maybe other VOCs. Like, why should I care about this if I'm just, if I'm just Ted Bettner, the farmer, in rural West Virginia?
Yeah, and I've been in West Virginia. One of my first studies was conducted in southern Pennsylvania and West Virginia, looking at methane emissions from conventional wells. And yeah, you're right, there are a lot of these wells. And if you are a landowner, this should matter because the negative impacts of these emissions can be enormous. Every time there is methane leaking from oil and gas infrastructure, it is bad news for the climate. It's also bad news for air quality and public health because of a whole host of other dangerous air pollutants that can be co-emitted with methane. And it's also bad news for the owners or the operators' bottom line because methane emitted is literally natural gas wasted, and natural gas wasted is lost revenue. And if I may add one thing here, Ted, these emissions are unnecessary and are avoidable because the technology to mitigate these emissions are widely available today.
Yeah, are oil and gas operators, or they're just not paying attention to all the methane coming out, or they're not, are there monitors on these wells to tell people that there's methane coming out, to tell operators that there's methane, or to alert landowners, or you're just finding this because there isn't any monitoring going on?
Yeah, I'm sorry, I didn't quite get that. Can you repeat that again?
No, I'm just wondering, like, how do, in terms of, a lot of these leaky wells, like you talked about that, this is something very fixable, and that the oil and gas operators could be fixing this problem. And I guess one question I have is, like, why don't they fix the problem?
Yeah.
That might be beyond your study a little bit. I'm sure.
Yes. So right. That's beyond the scope of the study. But I think one of the important things to note here is that it's really important to have studies like this that illustrate the scope of the problem, because if you don't have the data that underscores the magnitude of these issues, it's really difficult to take action on it. We need these sorts of studies to be able to say that these reductions are needed, these mitigation actions are necessary.
Absolutely. One of the things that really struck me about the study that was different too is, like, previous studies that have been in the Ohio River Valley or the Appalachian region, whether it's Ohio, Pennsylvania, and West Virginia, they've typically found that wells are emitting about 1 metric ton of methane annually. And your study finds that these wells are emitting about 7 metric tons of methane annually. I think if I got that right,
Yeah.
Can you describe, like, why did your study find such higher rates of methane leakage compared to previous studies?
Yeah, so the 1 metric ton or the 7 metric tons that you mentioned represents the average methane emissions. Okay. But there is a range on that. And some wells will have methane emissions that are well below this figure, and others that are well above that. I think the comparison, though, is not really an apples to apples comparison because there are methodological differences. Our study represents a synthesis of previous peer-reviewed and published site-level methane emissions measurements at low-producing oil and gas well sites, and it incorporated data collected by over 50 scientists using well-established ground-based measurement methods to quantify methane emissions from low-producing well sites in 6 major oil and gas producing basins in the US. So one thing I will note here is that the data that we consolidated and analyzed represents methane emissions not only from the low-producing well heads, but also from auxiliary equipment at the well site. So this would include emissions from separators and storage tanks and pneumatic devices and so on. Now, the 1 metric ton of methane per well, I believe that comes from a couple of recent studies that measured only the methane emissions from the well heads.
Yes.
But there are often lots of other equipment at low producing well sites from which methane leakages can occur. And methane emissions can be much higher once we look at the total well site emissions. I think another important point to note here is that our study also looked at methane emissions from the full range of low production rates. That is, we included all the sites with production rates up to 15 barrels of oil equivalent per day, compared to previous studies that focused on just the ultra-low production cohort of less than 1 to 3 BOE per day. And so the wide range of production rates that we analyzed in our study means that we are better able to assess the frequency and the magnitude of emissions, particularly from the high emitting, low producing well sites, which are important and are responsible for a significant proportion of the total methane emissions from these wells. The last thing I will mention on the methodological difference is that the measurement methods that were used in these studies that we analyzed do not require operator-provided access to the sites before measurements can be conducted. And this approach has certain advantages in that it increases the potential for obtaining methane emissions data that are more representative of both normal and abnormal oil and gas operations across a diversity of operators. And this can be especially important in characterizing the methane emission profiles for low producing wells nationally.
Yeah, that makes a lot of sense. And thanks for entertaining my, my methodological curiosity there. Sorry if that went too deep for a lot of people, but I think it's really important. These studies have come out over the last, say, decade, really, like last 10 years or so.
Yeah.
We've seen a lot of, on the ground studies of methane. And now we have, a federal orphan well funding bill. And one of the requirements, I believe, is to begin to measure methane as we're plugging wells. So this is something that's going to be happening a lot more, I'd say, over the next decade, is we're going to be finding out a lot more information, especially about these so-called orphan wells, or wells that don't have an owner and that are wards of the state. So we're going to be able to have a lot more information soon about some of those things. And one of the things I was sort of curious about is that in our study, we really looked at these ultra low producing wells, because the reason we looked at them is these are the wells that are producing, less than, 1 barrel of oil equivalent per day. These are the wells that could likely, need to be decommissioned soon, or plugged and abandoned, whatever word you want to use. And, if companies aren't in a good position, they could, go out of business, and these could end up being owned by the states. So we're very concerned about those. And I was just wondering, looking at these sort of ultra low producing wells, and I'd say a good chunk of these low producing wells, which is a huge share of them in the region, are teetering at being economically viable, or many of them are uneconomic wells. But I was wondering, like, when you looked at this in your study, were there are different rates of methane leakage, between wells that are producing like 1 barrel a day, or 5, or 10, or 15? Were they sort of leaking at the same rates?
Yeah. So one thing I'll mention is that all of these wells, whether they are ultra low producing or not, have the potential to emit methane emissions. And methane emissions can occur, due to the normal functioning of the equipment, or due to unintentional leakages. And we have seen these emissions at both ultra-low producing well sites and at non-ultra-low producing well sites. And so when looking at the national total, we estimate that about 3/4 of these emissions, of the about 4 million metric tons, are contributed by those sites that produce above 5 to 10 barrels of oil equivalent per day. When we look at the ultra-low production cohort, so those sites that are producing less than 1 to 2 BOE per day, they emit a far greater proportion of their production than the sites producing above 5. And we estimate on average that these ultra-low sites, producing sites, are emitting about 20% of their production, compared to less than 10% for the sites producing about 5 to 10 BOE per day. Now, there are going to be some regional differences in the relative importance of methane emissions from ultra-low producing sites, because some regions, like the Appalachian, are dominated by these ultra-low producing sites. So the Appalachian region is 90% ultra-low producing. So that's a significant number, right? And we estimate that their methane emissions account for as much as 60% of the total methane emissions.
Oh, wow, that's a lot.
Sites in the region, yeah.
Yeah, and that's a very big concern, with, we sort of have these, I think altogether I've heard, there's different numbers on this, of course, that about 10 million oil and gas wells have been drilled, in the United States since the beginning, since the mid 18th or 19th century, I should say. And yeah, a large part, a chunk of these, I think the estimate is, 2 to 3, 2.1 million of these are unplugged abandoned wells, or what's sometimes called legacy wells, that have been left around, that most of them aren't even accounted for. That sometimes when you go out to these well sites, you'll find wells that are in the database of the state agencies, and then sometimes you'll find dozens of wells, or several that aren't even in the database.
Right. Yeah.
That's what a previous study, I think, by Stuart Riddick showed, that in West Virginia, he went out testing all the methane, measuring methane at a couple of sites in West Virginia. And he said he found about nearly 6 times as many wells when he went out and did this field campaign than that were in the database. And he estimated a state like West Virginia that had about approximately 400,000 of these abandoned wells, which is just shocking, right? I mean, we only have about 56,000 in West Virginia that are actively producing. So it's like, tell me there's a whole nother 400,000 around here. So right. There's, the abandoned wells are an issue too, but the fact that these leaking wells are also these very ultra low producing wells. And, what part of my head is like, as the wells get older, I wonder if they leak more, they leak less, or they can just sort of, there's really no, did you all look at age in terms of leakage, methane leakage of the wells, or?
Not necessarily in terms of the methane leakage, because age as a parameter wasn't really reported in most of the studies that we looked at. But it is clear that a lot of these low producing well sites are pretty old. The average age is around 20 years old, but we have low producing wells that are more than 60 years old. And they're still producing, yeah.
And you looked at conventional wells here, right? You're not mostly, is that all most of the wells you looked at, it was conventional?
In the Appalachian, it's going to be mostly conventional wells. That's right, yeah.
So these aren't the wells that are grabbing the headlines, over the last, that have contributed to this, of the Appalachians sort of being the, biggest gas producing region in the country now. I think, Appalachia doesn't produce very much oil, but we produce a lot of gas, right. Especially since, the advent of high volume hydraulic fracking, horizontal drilling has taken place over the last, since 2008, I think.
Yeah.
That sort of grabbed all these headlines, but it's interesting to see all of these conventional wells come back in the spotlight. And the fact that when we're looking at methane emissions, that these low producing wells, the ones that are kind of an afterthought that a lot of people have, these are the ones that are producing half of the methane emissions. So I thought, to me, that's just astonishing that that's what's happening.
It is a big problem. Yeah, absolutely.
Yeah, just is it, some of the studies too I've looked at when they looked at methane emission sites, have looked at like sometimes it's just a few outliers causing these problems. So what share of the emissions are coming from a few outliers? If you have like 100 of these wells, or most of it happening in the top 10%, or is it evenly distributed? Do you know?
Yeah, it's interesting that you mentioned that. So there have been scores of measurement-based studies conducted here in the US, and a unifying result from those measurements is that a small fraction of oil and gas emitting sources, usually about 5%, account for a large proportion of total methane emissions, usually about 50%. And this is often referred to as the fat tail methane emissions distribution. And our study actually finds a very similar result. The top 5% of high emitting, low producing well sites are responsible for about 50% of the total methane emissions from all low producing well sites in the country. But what we have learned about methane emissions distributions is that the exceptionally high methane emissions can occur randomly in space and time. And that while it's really important to address those emissions at the tail of the distribution, we also cannot ignore the other sources representing the main body of the emissions distribution. Because while those site level emissions may be comparatively lower, the cumulative total can be significant, as is the case here for low producing wells.
Yeah, that's very fascinating. That makes a lot of sense. And I mean, I think like the study and what you've talked about has outlined, just how big of an issue this is, why we should be concerned about it. What I ask you, Mark, is like, what should we do about it? Like, is there anything that we can do? What actions we can take, or if there's anything happening at the federal level that could, reduce these methane emissions? Because as you said, we're just wasting this fuel. We're wasting it, and it's going into the atmosphere. So it's not even being used, and the potential that it could, heat 3.6 million homes, I think. And that's, if you're in West Virginia, that's more homes than the entire state. It's more than double of the homes are in the state. That's a lot. That's a lot of lost power and lost, just waste and inefficiency. So what are some things that are happening? What can we do to stop this from happening?
Yeah, so this study really underscores the importance of reducing the outsized methane emissions from low producing wells. It suggests that significant reductions of the climate warming pollution from oil and gas operations cannot be attained by leaving half the emissions on the table, right? And we have seen some actions already, particularly in states like Colorado and New Mexico, that have already advanced pollution rules that help address methane emissions from low producing wells. And these states show that the mitigation of these emissions is not only feasible, but also cost effective. And so the majority of low producing well sites and the production that these sites, from these sites, I should mention, are actually owned and operated by well-capitalized mid-size to large operators with hundreds to thousands of assets. And so importantly, what we do know is that the technology that's needed to mitigate these emissions are widely available today. And by estimates from the International Energy Agency, if we look at today's elevated natural gas prices, almost all of the global oil and gas methane emissions can be reduced at no net cost, meaning that the investment in the abatement technologies basically pays for itself because of the dollar value of the captured gas. So what can we do? There are some basic things, and there are some more advanced technology-dependent approaches that can be taken. And one of the recent studies, again, going back to the Appalachian, in Ohio, actually reported several instances of emissions that were audible, that were visible, and that were smelly, meaning that simple low-tech audio, visual, and olfactory assessments could be sufficient to determine there is a leak occurring, and from there to repair those leaks, which may be as simple as tightening loose valves and fittings, or closing fifth hatches on tanks that are accidentally left open, or replacing broken pressure regulators. All of these actions can reduce methane emissions. But that requires a deliberate effort to frequently inspect and maintain the site. And here is really where I think carefully designed policy actions can be essential. There are also, other approaches that are more advanced, including regular leak detection and repair programs using advanced infrared cameras to identify those emission sources and fix them. Other approaches include replacing the high and low bleed pneumatic devices with zero bleed alternatives and installation of emission controls, for example, vapor recovery units on storage tanks. The bottom line, Ted, is that the abatement technologies that are needed to reduce these emissions are widely available today, and it is feasible and cost-effective to deploy them to achieve significant reductions in climate warming pollution from oil and gas operations.
Yeah, I mean, that, I think if I told somebody, hey, at your house, 10% of the gas, your gas stove the gas that you use in your house is leaking out, and you're paying for it, and but it's leaking, I'm sure they would want to fix that, because if you're paying 150, 160 bucks a month for your gas bill, and if I said, hey, you're 10% of that gas you're wasting, wouldn't you like to get control of that? I think that makes a lot of sense to a lot of people to try to do something about that. And I know,
totally agree. Yeah.
So I'm trying to help people understand what we're talking about here and why it's so important too. And also imagine if that 10% of gas is leaking, it's leaking in your house, and it's unhealthy for the air and the kids that are in your house too. I mean, that's one way to sort of think about that. I mean, I know last fall, the Environmental Protection Agency released some proposed safeguards to cut methane and other harmful pollutants from new and existing oil and gas operations. And I think they might have, excluded, the proposed rule excluded some of the small well sites, perhaps some of the ones that you're considering the study. Does this report sort of highlight why the EPA might want to include these small wells into the rule? And do you think it'll be difficult for gas companies to comply with that rule?
Yes. So this study highlights why it's really important to include low-producing oil and gas wells in methane abatement policies. As I mentioned, the pollution from these wells account for about 1/2 of the total methane emissions from oil and gas production sites in the country. Significant reductions really cannot be attained by leaving that half of the emissions on the table. And with respect to your question about why this would be difficult, or why potentially, or will that be difficult, I think, for small operators, we have looked at the methane emissions. We have looked at the oil and gas production ownership for low-producing well sites in the country. And available data indicate that the majority of these well sites, these low-producing well sites, so about 80%, as well as their production, about 80% too, are actually owned and operated by these well-capitalized mid-sized to large operators that have hundreds to thousands of assets. And so in addition to the fact that the technology exists today and that it basically pays for itself to be able to deploy them, we think that this will be important in that it's cost effective and that it's feasible to reduce the methane emissions from these sites.
Yeah, that makes, I mean, it aligns too. One of the things that we found in our report, actually several reports, we did a report on stripper wells that we did called Stayin Alive, which I love that title. Diversified Energy, owns, we calculated using a database that they own about 30% of all the stripper wells. So these are wells that are highlighted in your study that are under 15 barrels of oil equivalent per day. So there are some of these larger companies like Greylock, some of them that own a big portion of these wells, including them. And, I think this study to me just highlights, we tend to think of leaky wells being on these so-called fracking sites all the time. And this report just really highlighted the need that you cannot leave out these conventional wells, which in our region make up 90% of the oil and gas wells in Appalachia. So we have to include those, and why it's so important if we're going to tackle climate change, and the fact that methane is so potent in the short term, and the social cost of not doing something today about that has huge ramifications. We can really be able to meet some of these carbon reduction targets and to meet some of these goals if we look at methane first, because it is so potent. And I think your study highlights where we go to find that. And one portion of that are these low producing wells that are scattered just all across the United States, but particularly in the several regions you looked at. But I just thank you for coming on. Thank you for discussing this. And if people want to download the report, find it, where would they find a copy of the study that you did?
So this is available from Nature Communications, and we'll be able to provide a link to that.
Okay, great. Well, thanks, Mark, for taking some time out on a Friday to talk to me about this. Thanks for getting in the weeds with me about the report. I hope we didn't lose some people, but these things that are so important, and I think the magnitude of the findings of this report should alert all policymakers that we have to include these so-called low-producing wells in any type of strategy of reducing methane in this country. And yeah, thank you so much for coming on, Mark. Really appreciate it.
Appreciate it. Thank you for having me.
Great.